Welcome to the Strengthening NGSS Proficiency for State Test. This is the second out of a three-part webinar series on kind of the NGSS is a marathon as the overall idea. And in the first session, we talked a little bit about what the foundations for even just getting started with the race, the starting line, and that is sense making. If teachers and students and yourselves, if you're an administrator, don't understand how to support that process and what the context is within which students are making sense of phenomena, it's going to be tough. And so this is talking about really specific structures that we see folks leaning into after having that initial foundation. So if you understand sense making, if using phenomena in lessons is going beyond just like phenomena as a hook, or like showing a GIF or a GIF or a video or something like that, and now we're like really digging into making sense of things. Now we're talking about what are some specific structures that we can do in our classrooms, with our districts to move things forward. And on that note, I'm going to introduce myself and my colleague, Julia. So hello, everybody. My name is Brendan Finch. My pronouns are he, him. I taught middle and high school science for 7 years in Los Angeles. I left the classroom 10 years ago now, which is crazy to me to build Rocketlit. Rocketlit is a leveled reading website. It's our first product. And about 6 years ago, we started working on Inner Orbit, which is the topic of this presentation today. And it really focuses, all we focus on are assessments for the NGSS. That's it, just phenomena-driven assessments. When we first got started, I wrote a lot of the assessments, and now my colleague Kate and her incredible team read way better stuff than I ever did because it's a marathon. And we started somewhere, and now we are where we are, and that's exciting. And I'm really excited to introduce my colleague Julia and co-presenter.
Well, thank you, Brendan. So my name is Julia, and I was a former teacher and a tutor in the Dominican Republic a number of years ago. And then I've been helping to build materials and support teachers with their implementation of the NGSS for the last 3 years, actually, not 2.5. And I said that last webinar. And in Orbit's district engagement manager. So if you're interested in trying it out and piloting with your teachers in the new year, please feel free to send us an email and I'll help you get that started.
Thank you, Julia. We're really excited to chat with y'all. Before we dive in, we want to explain what we are and what we do, just so you understand that context, and then we'll dive into our session. So what is Inner Orbit? It's kind of 3/4 things. So first off, what we're aggregating is a library of phenomena. So those are things that happen in the real world that you can explain with science knowledge and with skills and using the lenses of the cross-cutting concepts. So we want to have something we're doing in instruction, and then Inner Orbit provides phenomena for assessment. So a unique thing where you can look at something you've never seen before and take that knowledge and those skills you have from class and apply it. And we do that through the lens of these really specific scaffolded questions. And so we write questions about just the knowledge that students have, their application of knowledge to a cross-cutting concept or SCP, or all 3 dimensions in concert. And then all of those things are tied to really discrete data on our reports. So the idea is, as a district, you can sit down and say, like, what should we work on next? Or as an individual teacher or a PLC, you can sit together with your colleagues, give a common assessment, and then look at this data and say, all right, so modeling, doing pretty good on it, but students are struggling to develop a model to describe unobservable mechanisms. So it looks like that scale, proportion, quantity, cross-cutting concept in concert with that modeling standard was a struggle. And so we got to talk about, atomic level scale things or geologic time things. And that's really helpful. Also, even if you're an individual teacher and you're sitting down with a kid, you can filter this data by that, or you can sit at like an IEP meeting and hang out with a group of other stakeholders and say, like, here are some things that I see from my science classroom that could benefit, this student and where they're making progress and like where we have some work to do, which is great. The last thing we do is we do a lot of professional learning right now, right here. You're a part of it. Even if you're watching this as a recording, welcome. So we do a lot of research and context-based PD. We can come to you. You can come to us relatively in a virtual sense. And we model a lot of engaging classroom strategies. We'll go through some of those things today, which I'm really excited to go over. Everything is driven by teacher feedback. We get lots of feedback from people, which is exactly what we want. And we make things better. This is a picture of my colleague Erin over with a partner district in Connecticut. And so if you're interested in stuff like that, you can talk to Julia or talk to me about it. We'll have some contact info at the end of the presentation for that. But without further ado, let's dive into our topic for today. This is strengthening NGSS proficiency for state tests. And specifically, we're going to be exploring strategies and resources for growing NGSS practices beyond the sense-making foundations to prepare students for state tests. We're going to be here for about an hour, to be honest. Our agenda is going to go over first structures for students. So we want to look at this through 3 different lenses. So what are students doing? So students can do phenomena centers. We're going to talk about that a little bit. And then we're going to talk about annotating phenomena. So this is another structure that we strongly recommend. You can use in orbits phenomena. You can use other phenomena. We don't care. We just want to show you some tools you can use for students to engage beyond the sense-making basics. And then later, we're going to go over tools for teachers. So we're going to talk about collaborative common assessment building. And that is not just having like a district person build a common assessment and then people give it, but working with groups of teachers to build those common assessments. And then we're going to talk about formative assessments and instructional next steps. So what do you do now that you give in some assessments and really focusing in on your reports and saying, all right, I noticed this, now let's try this. Cool. And then for administrators, we want to go over some district data chats and talk about those things. And then also reflecting on those things and planning discrete goals for the future. So those are a couple things that we are focusing in on. At the end, we'll have some closing and some Q&A. We're really excited that you're here. We're really excited that you have questions. Write those in the chat. We will do our best to answer them as we go through, but we're really excited. So thanks for being here, y'all. And first, we're going to kick things off with some structures that we can explore for students. So again, just to provide further context, so we talked last time about initial sense making, just like do nows, like we wanted to give students like really like, just kind of like, we use this term like boop a phenomena on the nose and like, that's it. Like, we're not going to really get into it. We're just going to kind of like see it for a second, then go bye-bye. And so this is one of those structures. Julia's going to go into one, I'll go into another, that will give you ways for students to engage more deeply with phenomena. And they're not just like, go take a test. So Julia, I'm gonna pass it off to you. Talk to us about some structures that students can use or that we can use with students to explore.
Well, thank you, Brendan. Let's talk about it. And then, so the first one that we have is actually the phenomena centers. And this first strategy that we're going to review today is actually around the idea of giving students a formal practice with phenomena, or as we are calling them here, phenomena centers. And it is important to highlight that this informal practice fosters conversations and students to share their reasoning out loud, which helps them with the sense-making process overall. So this is a low-stakes sense-making practice. It tends to be less stressful for students than a formal assessment, and they might be more comfortable engaging with more rigorous questions. They also, it's easy to give them further practice and foster group discussions that helps them make sense of a phenomena together, leveraging everyone's strengths and benefiting from their peers in the groups. And then we can connect the idea between different phenomena by giving the same concept with different examples, by doing speed rounds or gallery walks, and students will see the same content applied to multiple scenarios. We're going to go a little bit into that right now. So moving on to this, let's say we're building up to this specific phenomena in the New York Science test. So this is all about there being fossils in Pendixie Fossil Park in New York, and they are meant to be underwater. So how did that happen? And we're asking students to provide one piece of evidence that supports this past plate motion. So this is an ESS standard, and it's all about plate motion. So how do we get students there with some scaffolding, with their groups, and with activities that engage in sense making? So we would practice with phenomena. So all of these phenomena are in the In-Orbit website. And you would print either 3 to 5 summative assessments for the same standard, each with different phenomena for students to explore in groups. So students would switch and have the opportunity to make sense of these 3 different scenarios tied to the same performance expectation that is building up to this scenario that we just saw in the New York Science test. So this helps them make deeper connections and spark curiosity too. And including these scaffolded formative questions in these assessments support students to build up to a rigorous sense-making question. So we would start first, maybe in the first station, we could start discussing how is there a forest in icy Antarctica? Then moving on to the second station, we would be looking at how a new island can teach us about the past. And in this final part, we would have students engage with why are rocks on the opposite sides of the ocean so similar. And at this point, we would have plenty of phenomena for this Earth and Space Science standard. So moving over, I'm going to kick it over to Brendan again to chat about a little bit more about how to annotate phenomena.
And thank you, Julia. And so this is intended for you to give students, I think, one of the threads that we find lacking in some of the curriculum that we see our partners choosing is the ability for students to connect not just the idea from the anchoring phenomena to an assessment phenomena, but more broadly to like lots of different phenomena. And so on In Orbit for the standard, we have like 5 or 6 different phenomena. And the idea is with this particular structure that students are able to see, oh, I get it. Like every time you teach me something in science, I'm going to see it here in this ice, in this forest. I'm going to see it here with these islands. I'm going to see it here with these rock layers. And again and again and again, everything we teach, we're going to see lots of different examples of these phenomena. And so I used to always want my middle schoolers to like get up and move around. And so stations are a great way to say, okay, we're all going to do the same things. We're going to work together in groups. We're going to move around while we do it. And that's awesome. So another way that we can allow students to kind of grapple with phenomena is to have them annotate on phenomena. And so first, before we talk about, like what annotation looks like, let's talk about like, why would we annotate phenomena? So why are we making this hard? So highlighters, am I right? So if you give students a phenomenon, you say, annotate it. You've probably done this before with reading. It's not going to require sense making. It's not going to require representing. It's just identifying. So students are going through and they're just identifying things in the reading. But what's really, really important is that phenomena are novel. And what we want to do is we want students to think deeper. We want students to question. We want students to make connections to their prior knowledge. And also, not all information is in a text format in a phenomena. And so as you give students these like graphs, these maps, so what we were just looking at, that Earth Science Standard is a really good example. Part of every single one of those, some of them have like the law of superposition, layers of different rocks. Some of them show maps and similarities between those things. Almost all of them show things were this way at some time, and now they're this way at another time. So lots of really abstract ways that students are seeing change over time being represented. And so by going in and annotating phenomena, we can give them opportunities to say, oh, like this is just like that. So the maps that are here are like those 2 different rock layers here, or they're like that GIF or GIF or picture that's over here. And so we can't just, throw this out to students and say, ask questions to the text. We need strategies for when they're stuck or overwhelmed. And because these phenomena are novel, we should expect students to get stuck. Like that's the idea. We want them to make sense of this. And that sense making may be a new way of thinking and learning. So I don't know where you're at in your classroom or in your district or where your students are at, but this might be a new thing. So we want to provide students with examples of ways that they can grapple with these new phenomena. And so we're going to look at a phenomena that's on the In Orbit website, which is, why do snowflakes have 6 sides? And what we want to do here is we want to give students this phenomena. And so what we've done is kind of truncated this. So this is like a small piece of that. And we want to allow them to go through and look at the phenomena and look at a question and answer the phenomena, look at the phenomenon question together. So the transfer stations that Julia just went over is an example of, students going through and just like answering questions together in groups. This would be adding an additional layer onto that, which is now when we're in a group, we're going to look at questions, surprises, connections, and predictions. And so first off, we want to encourage students to use these symbols to mark up prompts and questions rather than highlighting. Highlighting is not really our friend. And so this talks about the structure of water and how those molecules are arranged. That is why snowflakes have 6 sides. It is the hydrogen. And so the question that we're going to look at here is, your teacher asks if it's necessary to show multiple molecules of water when modeling differences between ice and water. How would you respond? And so students may say, like, what makes the attractive forces? So they may be looking at this and it says, when water freezes, the attractive forces between molecules causes them to arrange themselves in a specific way. What makes those forces? And so if I'm looking through this text, I might use a question mark as a way to say, like, do I need to know this answer right now to this question? This is just something I'm wondering as I'm going through this. Cool. And after that, we can use an exclamation point to show a surprise. And so, maybe I'm surprised to learn that water molecules arrange themselves in this 6-sided shape. And that is why, snowflakes look the way they do. And, it looks hollow in the middle. Maybe I'm surprised by that. I didn't know those things. And then we also want students to make connections between what they know and what they're reading about and learning about right here. And so we use these 2 arrows pointed in towards each other to say, a connection to something I learned in class before or something I've seen in the real world. And maybe we might say, like, I know that molecules are farther apart and moving around more at higher temperatures. And so when I look at molecules of water, that's true. And this talks about ice and water, so probably liquid water and the solid that is ice. And so that might be some prior connection that I can make. And then afterwards, we want students to make predictions. So the arrow going to the right is like, like what do I think is going to happen? And so we may say, like, yes, if it takes 6 water molecules to make an ice crystal, so the answer can't be no to this. So we'll go through the answers and take a look at those things here. So if we know that ice crystals need 6 water molecules or 6 waters to form, then we can say, it can't be, the answer cannot be no for either of these things, because, in order to model solid water or solid H2O, we need to have all 6 of those things. So students may go through this process and they say, okay, it can't be no, because we need to show that. So we can't just use one, we need multiple molecules of water. And that's what the question's asking. And then later on, they can go through the rest of this and say, okay, so, after reviewing these 2 questions that are left over, or 2 options that are left over, I can say, yes, it's necessary to have multiple molecules because the individual molecules are the same, but how multiple molecules are arranged together differs in water and in ice. Because in water, they're all kind of like cruising around, and in ice, they are locked together in this lattice structure. And so that's one different option for annotating phenomena. So as we go through things like this, and as I'm sure you've done this in your classroom, there are always things that we can do to do our best later on when we're implementing this. I strongly recommend that when you're implementing annotations, that you do this well before high-stakes summative assessment. So do not give this to your students as they're diving into a high-stakes summative assessment. You want to prepare them for that. Don't be like Brendan and train on flat ground before you run up a mountain. Train well before and in the right way. We also strongly recommend, as with everything, that you model these things for your students and use a prompt that includes, text, figures, graphs, data sets, tables. Make it complicated enough where you can really dig into it. And then also make sure to allow time for small group practice. So we want, as the teacher, to model this, then we want to slowly release their, the release control, allow groups to do it, and then have them be doing this as individuals. So a nice way to do that is say, like, we'll have like a do now, and I'll, have you do some annotations, and then as an exit ticket to like move you towards autonomy, and see if you can do this on your own after I give you some instruction on this afterwards. Except, as with everything that we do, that this may not help and may not work for all students. Some students have a really hard time going through and allowing teachers or students to annotate phenomena. I myself could not highlight and take notes on the sort of borders of books, and it didn't help me. I need to process things verbally. So just know that that's the case, and accommodate those kiddos. And then definitely teach students when to use it and when not to use it. So if you need to go quickly, don't sit there and write a whole bunch of questions. If you need to go quickly, read the questions, read the prompt, and blast through it. But if you have time to do this, then take your time. So just to address a couple of things in the chat. So somebody said, do you let students come up with lots of questions by themselves? Do you address the questions? And so you can choose to do this. I think it probably depends if it's a high-stake assessment and you just want them to stimulate their thinking, or when they sit in groups later on, maybe have other students in the group try to answer the questions. Like it's an interesting thing. And honestly, I think it's okay if you don't know the answers to all of those things. I read lots of things as an adult now where I can connect some prior knowledge to it and some things I can make sense of because I can associate them with other things. But frankly, sometimes you just don't get answers. And so you just don't know. And honestly, that's okay. You got to get a little comfy with being uncomfy when you're making sense of new things. Somebody else asks, do nows. So teach like a champion. So yeah, I have read that book as a part of professional development in my own classrooms. And do nows were just a really common practice that we would use at almost all the school sites that I taught at to engage students initially. I don't know if this particular slide comes from Teach Like a Champion, but I feel like that specific book has had so much trickle down into the lexicon of like what we use in education that maybe it originated there. I don't know where that word came from, but that is a great question and a great reference to a great book. And if you haven't read Teach Like a Champion, I would recommend checking it out. All right, great. So we talked about some structures that we can use for students. And so once students have that base laid of, okay, we've identified that you can make sense of phenomena. Now we want to give you some structures to practice that in groups or to engage one-on-one with a phenomenon and a question. And so if they've been doing transfer stations and doing annotation, that's great. Now let's talk about what kind of behaviors, what kind of activities teachers can engage in to help either themselves or their students to engage in this. And so these slides come from a series of, or a session that we did at NSTA last year with a partner district in Maryland. And the two coordinators that my colleague Erin co-presented with talked about their journey into building common assessments. And it seems to us across all of the accounts that we support that if groups of teachers can sit together, they can build assessments together, they can administer those, and then they can look at the data together, that right there is a very powerful thing. And so if we give opportunities for, at least at first, maybe the district coordinator to build those things, and then later on, we say groups of teachers are going to come together and build these together, that is the goal. And so just some things to consider when jumping in to common assessments, if you haven't yet done that. We have lots of different ways to jump in here. Every journey is different. And so in the session that they went through, they reflected a little bit on the differences between 2018 and 2024. There are a lot of things that have changed in the world in those 6 years. Even our understanding of the standards and the availability of curriculum and resources and professional learning has changed. I wouldn't say there's dramatically more PD around the NGSS, but we're on our way. And so that's important. And it's also important to know that the journey can go backwards. So as many of us saw during the times of COVID, where we'd been making lots of progress in the NGSS, and then there was just some regression that happened. And that's totally fine. Because honestly, there's no one right way to like jump into this journey. And when we're moving forward in our personal lives or our teaching practice or with NGSS assessments, you just have to start somewhere. And so what we want to do here is kind of work through some of the different contexts, some of the different starting points, and some different places where you can jump in to that journey. So you can think about this through the lens of a team, of a school, or of an entire district. And so depending on your context, think about these different ways to look at that. So one way to think about this is practice jumps. So what are some ways that we can kind of like practice? And then getting off the ground. So not just like, the little boing, boing, boing with that little pupper there, but actually leaving the ground and making some progress. And then launching. So actually embracing this. And I love the chaos of this GIF because that's what sometimes things are like. We're going to try something new today. Like cross your fingers. Anyways, so practice jumps. What are practice jumps? So practice jump in the context of common assessments would be teacher analysis of sample assessments. One of the ways that we suggest doing this is taking it as a student. So when you have a PD session with teachers, build an assessment, assign it to them as though they were students, have them take the assessment as a student, have them pull out different misconceptions, have them speak about the process, like metacognate about what was it like to make sense of that phenomenon. And then also have them identify barriers. So if you were a student and you were sitting in there and you were taking this, like what are some things that students would struggle with? What are some things that you struggled with? And that's really, really important. And after that, you can also do some analysis on some sample data. So I'm not sure if you've experienced this, but we see sometimes that there are a lot of feelings that come up when you look at data about your own students and about yourself and about your colleagues. And so instead, let's look at data that's not yours. And the question that we want to ask them is, like, look at this data that is not your data, but imagine it was, and what would you do about this? And then what we want to think about as we're laying this groundwork for common assessments is what could our teams accomplish if we had systems to collaboratively analyze 3D student data? What if we could do this all the time with each of our units and each of our lessons? And that's a great starting point. All right. So once we've done some practice jumps, now we want to actually get off the ground. So what this looks like in many of our contexts is that teacher groups, and those are, so any grouping of teachers, it could be the entire PLC, it could be like 2 teachers that teach biology together, or all of the district-wide chemistry teachers. But we want them to build one common assessment, and we want students to take said common assessment. And then there needs to be a session. We need to carve out time. So either in a PLC meeting or like a PD session. I feel like our New York districts use like superintendent's days and stuff like that for data analysis and collaborative grading. So you've got to look together at the full responses. You've got to look together at the questions, do some question level analysis, some reporting analysis, and then figure out what you're going to do. And the figure out what you're going to do is called reflecting. And so we need to gather insights. What did you see about the test? What did you see about the questions? What concerns do you have? And then what else do you need? And so this is all a part of the process because as you know, you teach a lesson one time to first period, and as you go through the rest of your day or the rest of your week, and you teach that lesson more times, you learn things. You gather insights. You figure out what things are concerning, what things are not. And then you know what you need to do in the future. And that is the process that we want to go through. Once we've done practice jumps and once we've like gotten off the ground, then we need to embrace the lunch. So we have to do this thing. And one of the ways that one of our partner districts in Maryland did this is they built these common 3D assessment committees. So teams of teacher leaders came together and they built these things together. One of the things that they considered was what type of assessments do we need? And then they select items that align to their scope and sequence. So oftentimes, we'll have like a big old document that has all of our units and all of the standards that we're going to cover. We identify some key standards, the types of assessments. Are these going to be summative assessments? Are they going to be formative assessments? Are they going to be like a diagnostic assessment or like a practice state test assessment? So what do you need? And then you can build that thing. So it can also look like this. So you can build a bank of assessments. So that common group can say, we're going to give this assessment between February 2nd and February, like 12th. And that's what's going to happen. Or you can build out, the common assessment group can build out maybe like 10 different assessments and say, here you go, 7th grade team. When you're ready for this, you give assessment 1, assessment 2, assessment 3, assessment 4, assessment 5. So those are nice ways to roll this out, either to give everyone windows or to give everyone a bank and have them roll. And then we need to also, step back from each of those assessments and look at the entire assessment system. And think about this. So how do our assessments build on each other and towards our common 3D phenomena-driven assessments? So not just what is this common assessment team doing, but what kind of do nows, what kind of exit tickets, what kind of formatives, what kind of summatives are we giving in our individual classrooms that lead towards this common assessment? Because again, we want to make sure that we're prepared for the thing that we're going to assess students on. So again, I just want to go back through this one more time to review. There are, 3 different ways to kind of like jump in to common assessments. At first, you can do practice jumps where you analyze data that's not yours, assessments that you're not going to give your students. You can get off the ground by having one district common assessment that you give out to your students and look at the data. Or you can get a group of teachers together, really embrace the lunch and have people work collaboratively, build these assessments, roll it out, and then do some reflection on our classroom practices and our assessment system as the year moves forward. And so something I'd like you to consider right now in the chat is, what are your next steps, all of y'all, in building out assessment systems in your district, school, or classroom? So respond in the chat. Let me know, what do you see as your next step? Are you doing practice jumps? Are you getting off the ground? Are you embracing the launch? Are you honing some Olympic level system? Let us know what your next steps are. Great responses, y'all. I want to make sure that we move on. Please, if you're still typing something, write it down. There is no need to stop. Thank you for sharing your thoughts. I love the idea of, practice jumps as being a starting point. If you're just getting started, that's cool. Lots of people, as you can see right now in the chat, there's lots of people that are just getting started. And so that's fine. And if you're at the point where you're getting off the ground or you're embracing the lunch, that's fantastic as well. I love this. Yeah. And thank you so much, y'all. Obviously, so, Orbit is a structure that you can use to implement these things. But if you're looking to you can implement all of these things in any way. So teachers can write their own assessments. You can use current assessment systems and all of that good stuff. So now I'm going to pass it off to Julia. And now that we talked a little bit about all of these different ways to get started with common assessments, Julia is going to walk us through kind of ways that you can scaffold up to 3-dimensional questions. And so what we're doing here is we're building upon that common assessment sort of journey. And this is a layer that we usually add into when people are building common assessments. Like, what kind of questions do you add into your common assessment? How do you choose those questions? How are those questions designed? Why do you have that question and not that question in the assessment? And so I'm going to pass it off to Julia to talk a little bit more about how we think about scaffolding up to 3D questions.
Of course. I think there's a little bit of, yes, and sense making is hard. So as we know, students would struggle with rigorous questions, but yeah, so we want to prepare them for those challenges in smaller chunks. And then we can also gather data to help scaffold them up. And how would we do that if it's not leveraging our dimensions? So let's dive into a specific question. a three-dimensional question here. And let's say this is an assessment question that we gave, and this is a third grade question, and it's a question that is targeting all three dimensions. So we want to make sure that we can build up to these three-dimensional questions and gather data that really represent where students are at. So as we mentioned before, leveraging dimensions is key. And the first thing to note is that the right assessments are going to lead us to the right data. So we need to build assessments that are going to give us that rich data that we're looking for. So let's make sure to include scaffolded questions and understand where the struggle is. And I'm going to show you how those questions look like and how you can do that with it. But here, only 53% of students answer the question correctly. So how could we dig deeper in understanding where the struggle is?
Let me add in a little bit of context, Julia, here. So the phenomena here is about moose populations and where do moose live within the world. And so in that question, it talks about global warming, warming up the planet, and the fact that this may impact where moose live based on climates and where those climates are right now and how that climate may change over time. So just for a little bit of context, that's the phenomena that we're looking at is climates of the world, the moose locations or habitat where moose are found right now. And then considering this shifting system that we see with climate change, how are moose going to have to adapt in order to meet those changes with antlers, right? Are they antlers? I can't remember. It doesn't matter. All right. Back to you, Julia. Sorry.
So let's see how we could bridge that gap again between content questions and 3D questions. So as you can see, there's kind of like a way that we're going here. However, 2D questions will give you the more detailed information with separate data for both the cross-cutting concept and the science and engineering practice. This will also help us scaffold up to these three-dimensional questions, and they'll be very, very telling for us to understand and determine if students are ready for the level of rigor that a three-dimensional question requires too. So let's see how they look like. So in this first question that we would create in a common formative assessment, we would include a non-grade level knowledge question. So this is a DCI only question. We're just asking if students understand the content in this lesson, which again is about moose populations around the world and how they've changed and how basically it's all about adaptation and survival of the fittest. So are students ready to be assessed in the content of these PE? So this is kind of like what this question will tell us. Do they understand the concept, the content in the lesson of adaptation at this point? Then moving on to the second question, here's when we kind of like build it up a little bit. So here we're asking students to apply the content of this lesson and also apply it through the lens of the cross-cutting concept. In this case, we're intentionally leaving out the SEP for students to identify cause and effect, applying what they learn about adaptation. So we're giving them two pictures. Why are moose not found in dry or moderate climates such as deserts? So at this point, we're just asking them again about cause and effect and adaptation, leaving intentionally out the science and engineering practice. And then we do the same thing with the SEP. So we're asking them now, how can you engage an argument from evidence with what you learned about adaptation? Intentionally leaving out the cross-cutting concepts. Can you do those two things alone? And then here the question is asking them, which of the following pieces of evidence would correctly support the claim global warming is warming up the planet and this would change where moose can live? And this will all build into our data. So now that we are scaffolding from representation to sense making, it'll help you build up to a three-dimensional question to the one that we had in the beginning. That was a more rigorous question, the one that's the type of questions that students would see on state assessments too. So by separating the dimensions and building up in rigor, we can help our students make sense of summative questions or three-dimensional questions, and you will gather the data that will help you make informed instructional decisions at the end. And as we can see here, going back to that 53% that we talked about in the beginning, here we see that students actually understand the content of the lesson because 71% of students could answer questions about the DCI correctly. And then 65% actually of the questions asked about science and engineering practices were answered correctly, but only 38% of the ones, including the cross-cutting concept, were answered correctly. So now we see that their struggle really, according to this data, students are struggling identifying cause and effect. They're not necessarily struggling with the content or with the science and engineering practice, which in this case is engaging an argument from evidence. So what we would do at this point is we would bring this data to the PLC to have deeper conversations like the one we're going to model shortly. And yeah, so now I'm going to kick it over to Brendan to get us started in that data chat.
Awesome. Okay, so now we've gone over a bunch of different structures and systems that we can use with individual students and with groups of teachers, and considering common assessments, and then what types of questions to add into those to kind of scaffold up. Because if you just build common assessments, and we see this happening often, and those questions aren't thoughtfully composed, the data you get at the end might not be super helpful. So thinking about how you're scaffolding those questions, how you're asking them about specific pieces of the standards is really, really important. So now let's talk about what an administrator might be able to do in order to move this forward. So now we're working towards that proficiency. We've got students doing cool things in phenomena centers and annotating phenomena. We've got teachers working together, building common assessments. We're looking at how those questions in those assessments scaffold up and give us really, really interesting data. Now let's talk about what we do with that data. And so the first thing that we're going to do with that data is analyze it. So really, really important in our PLC chat, and most of the PLC processes that we see involve some degree of analysis, action, assessment. And InOrbit is a great way to get that assessment in place. And so using this kind of formative assessment journey that we see here, we're going to talk about the InOrbit PLC data chat protocol. So our colleague Aaron has written this protocol. It's something that now hundreds of thousands of teachers of hundreds of thousands of students have used. And we find it very, very effective in breaking down the data that you get from our assessments, or any data that you get from your common assessments. So the first step in the protocol is to observe. We want teachers to look at the data and see things. Next, we want to say, now what does that data mean? What does this suggest? Make connections between pieces of the data. And almost lastly, then we want to find implications. So this is where we always go right away. I want to solve the problems here. But what we want to do is first look, and then make connections, and finally say, what next steps can we take to move things forward with our data? And at the end of every process, we want to reflect. How did this go? What do we want to change in our assessment for next time? What do we want to change in our data for next time? How should we change the way that we talk about our data next time? So these are different things that we can talk about in this process. And so now Julie and I are going to walk through kind of a model data chat using the protocol that we offer for teachers on InOrbit, and we'll walk through each of these different steps. So the first step that we start with is observation. And this is tricky, and it always requires modeling because we want to solve problems. But this is not the time where you solve problems. This is the time where you see things. So the question to pose is, what do you see? And so some sentence stems for this are students excelled with blank, or students struggle with blank. And the idea here is that we only record observations without judgment or interpretation. So Julia, what's something that you see in this data here?
So I notice students excelled applying concepts of statistic and probability to analyze and characterize data. What do you see?
I like that. So I noticed that so students did the same on standards associated with grade levels 3-5 as with grade level 6-8, which is really interesting to me. And I guess I also see that students struggled to construct, analyze, and interpret graphical displays of data in our large data sets, specifically to identify linear and nonlinear relationships, that really specific thing. So it's interesting that they did well with statistics and probability, but they struggle with that linear and nonlinear relationships. Anything else that you see, Julia?
I also see that what they struggle with involves large data sets. So maybe, is it possible that I am going over one step and I should not make assumptions just yet?
I like that you caught yourself, because the next thing that we're doing after we're making observations is we're doing some analysis. So that analysis should involve, what does the data suggest? So like, why is this? Students struggle with X because of Y. So now we're making sense of the data. Students understand A because of B. These are, making sense of what the data says, and then why we think the data says that. We're not problem solving at this point. Don't say what you're going to do. We're just saying, what does the data suggest? What does it say? So what are some things that this data suggests for you, Julia?
So as I was mentioning before, students may have struggled with constructing, analyzing, or interpreting graphical displays because of the linear and nonlinear relationships, but also because of the larger data sets that specific element of the SEP involves. What do you notice?
And I'm just annotating this so folks see exactly where you're seeing this. So I like that a lot. I think that's really specific. I think what else is really interesting to me is that so doing things with mean, median, mode, and variability. So these are also math skills. So what this tells me is maybe in math courses, mean, median, mode. I taught 6th and 7th grade math. We would talk about these things, and it was something that we covered. So this may be actually covered in multiple subject areas, which means students have lots of reinforcement on this. But what I didn't do as a math teacher as often as I should have is have students look at relationships between variables over time. And so that graphing, it was always a bit abstract for at least my students. And so I didn't go over that as much. And so I think the burden of that fell on the science teacher. So what I'm wondering is mean, median, mode, and probability were something that the math teachers maybe like really nailed with them. But because it just fell on the science teacher, interpreting those graphical displays may have been a struggle. Anything else that you see in this data?
I also see that they struggled analyzing and interpreting data, or they struggled a little bit less than with constructing with nonlinear and linear relationships, but with analyzing and interpreting data to determine similarities and differences in findings. So maybe those two things and the evidence for phenomena could also be correlated with something that comes before in the 3-5 level. So we could dive into that data deeper to understand how that looks like.
I see a comment in the chat too that maybe students don't understand the differences between linear and nonlinear. So sometimes, that in and of itself, just the jargon that's used in these standards can be one of the ways that you can look at that. So just to be really clear, so the questions on NEORBIT are tied to really specific pieces. This is a screenshot of actual data from one of our actual district partners. And we're looking at this, as a group so that we can kind of figure out, like, what does it look like to look at this data? And now that we've gone through some analysis and some observations, let's talk about implications. And now it's y'all's turn. So what are some of the implications of this data for teaching and assessment? So if this were your students took this test, you're a middle school teacher, congratulations. What an awesome group of kiddos that you're working with. Now tell me, what would you do to extend students' learning? If this was your data, what would you do to support students' growth? And I think what we want to focus on here are specific action items. Like, what is the step that we want to take? Who's going to do that thing? And when might that get done? And so in the chat, consider what are some of the implications if this was your data in your own classroom for teaching and assessment. And make sure, just one more check, that your messages align to everyone. If you want to share them with everyone, if you just want to send us a message, obviously, Julian, I would love to hear from you. But if you want to answer this prompt, what are the implications of this data for your own classrooms? Make sure your Zoom chat is set to everyone and not host and panelists. So many good things in the chat I want to call out. Thank you so much for your responses. So I really, really like, so folks are looking at what's happening in 3.5, where graphing is being taught. I really like the idea. So somebody mentioned, like retracting the lowest area. I'm not sure if that was reteaching, but that's super duper interesting. I think follow-up instruction is something we must focus on here, Nathan, and that's the whole idea. Figuring out how we can follow up on these things is really, really, really important. And so data from graphs and annotating those graphs is a good idea too, Josefa. I really, really like that. So, what confused you and why? What would you like me to reteach and why? Having students consider where they are. I think this is a great exit ticket is kind of that analysis that students do and say hey, what were you confused about? What do you understand the best? And what else do you need from me? That's something you just put on the back of a paper or at the end of a digital exit ticket to have students reflect on those things, which that could be something you do with just a graph, which is fantastic. Yeah, so a lot of things about graphing. Also, struggling with words that are used in English classes like seldom, numerous, deplete. I think that reading and processing things is really, really smart as well. Awesome. Oh my gosh, yeah. Analyzing different types of data. Small groups is a great way to go into this. So many good things that y'all are focusing on in here. I love it. I'm not going to read every single thing, but I love all of these comments. Thank you. And if you're still writing something in, don't stop. Please tell us what you're thinking. And thank you for sharing your thoughts and your ideas, y'all. I love it. This is fantastic. Cool. So now we're going to go into the final step. And once we've gone through some initial work on observing our data, on analyzing our data, and now thinking about implications, we want to reflect on our process and our data. So one of the first questions is, what questions about teaching and assessment did looking at the data raise for you? Did questions of equity arise? How so? If not, why not? So I see folks already in the chat, like popped right over to this, looking at students that are multilingual learners and considering, the connection between these English language terms and the terms we use on our assessment and whatever we're doing in instruction. Are students familiar with these things, or are we asking them about jargon that they're not familiar with? Equity also looks, there are a lot of different ways that equity looks for in the context of assessment. So thinking about that is important. And then also, what additional analysis would you like to complete? And then why would you like to complete that analysis? Finally, so just to go back to that for 1 second. So some folks in the chat said, there should be spiraling, there should be reteaching that goes on. Like, how do I follow up on this data? Well, how do you know that those follow-ups were successful? Like, just because we talked about graphing, or we saw that graphing was a struggle and we re-taught about graphing, is that enough? Like, what can I do to make sure I move the needle in the direction that I wanted to? Super, super important. And then finally, so what do you want to try in your classroom as a result of this data? If you look in the chat right now, there are a whole bunch of different suggestions for exactly what you can do in the classroom. People agreeing with each other about things that they've found be successful with their students, which is absolutely fantastic. And so on that note, I'm going to leave this as a plug for next time. And we're not going to dive into these key strategies right now. We'll actually dive into this at the beginning of our next webinar. And so this is now what? So once we've gone through an assessment and we've looked at some analysis of that stuff, what is some action that we can take? And so there are 3 structures. And again, we're not going to go over for the sake of time these things during the webinar today. We'll save this for next time. I want to respect y'all's time. And so one of the things that we talked about in our very first webinar, and we're going to revisit again in webinar number 3, are science talks. So what are ways that we can engage students in productive talk using talk moves around a phenomenon? And so you can also do this in response to your assessment results, and you can layer on additional complexities to that as well. And then we'll go over some strategies for differentiated review. So now that you've got this data and you're looking to, see if we can move things forward with students, how can we differentiate the review? And then at the end, we'll also talk about gallery walks as well. So I always found gallery walks, I used a lot of Kagan strategies and a lot of like get up, hand up, stand up, pair up things, and moving around the classroom to make sure that students are moving. Gallery walks are a great way for students to showcase their own work and for other students to reflect upon the work that other students have been doing. But with that, I'm really excited that y'all were here. I'm really excited to wrap up this webinar and give y'all some time to process this. So thank you for going through all of these things. Just to be clear, the reflecting and planning discrete goals afterwards, this is going to be something that we cover in our next webinar so that we don't go over time, because we want to do these things in the time that we say that we're going to do them. So thank y'all so much for joining. Julie and I will hang out for a couple minutes. If y'all have questions, drop them into the chat. But otherwise, thank you so much for being here. We have a webinar coming up in a couple of weeks. And so Julia's dropping a bunch of links in the chat. Thank you so much, Julia, for doing that. So if you want to find a time on our calendar, you can click on that first link that says find a time on our calendar here. If you want to pilot Inner Orbit, if you want to sign up for our next webinar, which is going to involve, so it's called Peak Performance, the Pursuit of NGSS Assessment Excellence. So we have the pleasure of working with some districts that are way farther along in their assessment journey. And they are honing these Olympic level systems of assessment and of instruction. And so we're going to go over some of the strategies that they are using in gathering useful data and responding to that data. And we have lots of other things that we're going to talk about too. So we're really excited about that. So click on that link as well. We would love to see y'all there as well. If you want, you can follow us on social. This video will be on YouTube later on. So if you want to go watch more of Julie and I talking, then you can go on YouTube or subscribe and you'll get notified when we publish new videos. Or you can send us an email if that's something that you're into. Thank you so much, y'all. Have a beautiful rest of your day. If you have questions, we are happy to answer them, but we are grateful for you being here, taking the time and space to grow your practice and reflect. And it was great to have y'all here. Take care, everyone.